If the masses of the two bodies are equal, that is m1 is equal to m2. m1 is equal to m2 means if the masses of the two bodies are equal, then let us take the relations and substitute m1 is equal to m2. v1 is equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 u2 by m1 plus m2. In this relation, if you substitute m1 is equal to m2, then the first term becomes 0. m1 minus m2 by m1 plus m2 into u1 becomes 0. 2m2 u2 by m1 plus m2 becomes 2m2 u2 by 2m2. m1 is equal to m2, hence we will get 2m2 in the denominator also. Then 2m2 gets cancelled, so we will be left with u2. Then v1 is equal to u2. v1 is equal to u2. In the second relation, v2 is equal to 2m1 u1 by m1 plus m2, 2m1 u1 by m1 plus m2 plus m2 minus m1 by m1 plus m2 into u2, m2 minus m1 by m1 plus m2 into u2. By substituting m1 is equal to m2, the second term becomes 0. And in the first term, 2m2 u1 by, you will get 2m1 in the denominator because m2 is also equal to m1. So 2m1 gets cancelled and we will get v2 is equal to u1. From the first relation, we get v1 is equal to u2, and from the second relation, v2 is equal to u1. What is the meaning of these relations? That is, if two bodies of same mass collide with one another, then the first body gets the velocity of the second body after collision. After collision, the velocity of the first body becomes equal to the initial velocity of the second body. v2 is equal to u1 means the velocity of the second body after collision is equal to the initial velocity of the first body. So the bodies exchange their velocities. The first body gets the velocity of the second body and the second body gets the velocity of the first body. Now this is what happens if two bodies of same mass collide with one another. If u2 is equal to 0, that means the second body is at rest before collision. If the second body is at rest before collision, then mathematically we write u2 is equal to 0. In such a case, the first relation v1 is equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 u2 by m1 plus m2. This gets reduced to v1 is equal to m1 minus m2 by m1 plus m2 into u1. The second term becomes 0. Hence, v1 is equal to m1 minus m2 by m1 plus m2 into u1. We have to apply this relation when the second body is at rest to find the final velocity of first body. To find the final velocity of second body, we have to use the relation v2 is equal to 2m1 u1 by m1 plus m2 because the second term becomes 0. In the equation, v2 is equal to 2m1 u1 by m1 plus m2 plus m2 minus m1 by m1 plus m2 into u2. The second term m2 minus m1 by m1 plus m2 into u2 becomes 0 because u2 is 0. Hence, we will get v2 is equal to 2m1 u1 by m1 plus m2. So, when collision occurs and the second body is at rest before collision, then for finding the final velocities, we can use the relations v1 is equal to m1 minus m2 by m1 plus m2 into u1 and v2 is equal to 2m1 u1 by m1 plus m2. If u2 is equal to 0 and m1 is equal to m2, that means the second body is at rest and the masses of the two bodies are equal. That means one body colliding head-on with another body of same mass at rest. The masses are equal and the second body is at rest. Then substituting these two values in the first equation, v1 is equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 u2 by m1 plus m2. Both the terms becomes 0 because in the first term m1 is equal to m2, so m1 minus m2 is equal to 0, hence the first term becomes 0. In the second term, u2 is 0, hence 2m2 u2 by m1 plus m2 is also equal to 0, hence v1 is equal to 0. Take the second relation, v2 is equal to 2m1 u1 by m1 plus m2 plus m2 minus m1 by m1 plus m2 into u2. In this relation, m1 is equal to m2 and u2 is equal to 0, hence the second term becomes 0. So v2 is equal to 2m1 u1 by m1 plus m2, but m1 is equal to m2. Hence 2m1 by m1 plus m2 gets cancelled and becomes 1. Hence v2 is equal to u1. v2 is equal to 2m1 u1 by 2m1. 2m1 gets cancelled and we will get v2 is equal to u1. Hence the final velocities are 0 and u1. That means the first body comes to rest and the second body flies off with the velocity of the first body. If two bodies of same mass are taken, if one body is at rest and if the second body comes and hits the first body, then the moving body comes to rest and the body at rest flies off with the velocity of the other body. A body moving with a velocity collides with another body of same mass at rest, then the body comes to rest and the second body flies off with the velocity of the first body. A lighter body colliding with a heavier body at rest. A lighter body colliding with a heavier body at rest. And this is mathematically written as m2 is far greater than m1 and u2 is equal to 0. m2 is far greater than m1 and u2 is equal to 0. That means a lighter body colliding a heavy body at rest. In the figure, m1 is very small and m2 is very large and u2 is equal to 0. In this case, we can ignore the mass of the first body. So m1 is approximately equal to 0. Since the second body is at rest, the velocity of the first body after collision is given by the relation v1 is equal to m1 minus m2 by m1 plus m2 into u1. The velocity of the first body after collision is given by the relation m1 minus m2 by m1 plus m2 into u1. In this relation, we can take m1 is approximately equal to 0. Hence, we will get minus m2 by m2 into u1. Hence, it is minus u1. So, v1 is equal to minus u1. That means the first body bounces back with the same velocity. It comes back with the same velocity. Then take the velocity of second body. If the second body is at rest, then the final velocity of the second body is given by v2 is equal to 2m1 u1 by m1 plus m2. 2m1 u1 by m1 plus m2. Since m1 is approximately 0, v2 is 0. So the second body remains at rest. The second body remains at rest and the first body flies back. This is shown in the second figure. Minus u1 in the opposite direction. u1 is from left to right and minus u1 is from right to left. A heavier body colliding with a lighter body at rest. So m2 is far less than m1. So m2 is far less than m1 and u2 is equal to 0. So u1, a large body, a body of heavy mass, is colliding with a lighter body. Then we know the final velocity of the first body is v1 is equal to m1 minus m2 by m1 plus m2 into u1. In this relation, if we ignore m2, if m2 is taken approximately equal to 0, then we will get v1 is equal to m1 by m1 into u1. So v1 is equal to u1. That means the heavier body moves with the same velocity in the same direction. And then to find the velocity of the second body, take the relation v2 is equal to 2m1 u1 by m1 plus m2. v2 is equal to 2m1 u1 by m1 plus m2. Since m2 is ignored, its mass is considered to be 0, then v2 becomes equal to 2u1. v2 is equal to 2u1. That means the second body flies off with double the velocity of the first body. With double the velocity of the first body. The first body travels with the same velocity, but the second body travels with double the velocity of the first body. So whenever a heavier body collides with a lighter body, the heavier body moves with the same velocity, but the lighter body moves with double the velocity if the second body is at rest before collision.